Hello students, today I have come up with a new topic, that is solutions. Previously we have done different different topics regarding matter around us, that is separating solid mixtures, where we discussed about, or where we understood where how to separate solid mixtures. In next topic after that we did separating solid liquid mixtures. Previously was solid mixtures, now it's solid liquid, the mixture of solid and liquid. Okay, and now today we will discuss about the solutions completely. Okay, that solutions, whatever the product we get after mixing two compounds or two things. Okay, so in this topic we will try to understand the concept of solubility and its usefulness in our daily life. So first of all, let us go with the definition of solution. What is solution? Solution is, it is a mixture in which the components dissolve in each other completely are called solutions. So there is another term here. There is another term, that is mixture. So mixture is, it is a mixture of two components. Okay, that is, it is two component where we can see that two things are there. Okay, if we are mixing some two or three, more than two three things, okay, together to make a product. So those two three, if A, B and C, we are mixing A, B, C to form Z, then A, B, C are the mixtures. Okay, and what the Z is forming, where we can't see the A, B and C, that is the solutions completely. Okay, so this is the kind of difference between a mixture and solution. Mixture in which the components dissolve in each other. Now solution is, if I talk about the example is here, the example is mixture of sugar and milk. Okay, in mixture of sugar and milk, we know that there is a milk, there is a sugar, but once we mix it, okay, we mix the sugar in milk, what we get the sweet milk, isn't it? We don't see the mixture, one of the mixture, that is the sugar. So now it's a soluble, that one completely dissolves in another. Next is the salt and water. We know that there is a salt, we can taste it, but we cannot say that we cannot show no this is a salt in a water. We can only find it once we taste it. So the solution is the components dissolving completely in each other. So salt water solution, lemon juice in water, etc. So we use many such solutions in our daily life, isn't it? So mixtures of sugar, milk, salt and water, lemon juice, etc. So many different kinds of solutions are manufactured and are used in the labs and factories to make different products. So now we'll move. Okay, these are the examples. Okay, in another is okay, and remember that in solution there is all, okay, this solution, okay, this forming this solution, okay, forming this solution, there are there will be always two components, that is the solute and solvent. Okay, so solute is the solid thing, solute is the solid thing, or the thing that will get mixed into a liquid. If a liquid will be mostly the solvent. Okay, liquid will be the mostly the solvent. So liquid is solvent, this is the solvent, this is the solute. Okay, this is solvent and this is solute. Solute is that something that will be mixed in a liquid, and the liquid is a solvent, and together solute and solvent will form a solution. Okay, now in this case, mixing of ice and mixing of salt and water, salt is a solute. Now this salt is a solute and this water is solvent. Got it? And whatever we get, this salt water is a solution. In this case also, carbonate water is a solute, and this is the orange juice is solvent, and they form a carbonated drink. Okay, so in this case these two examples are different. This is a solid liquid, this is the example of solid plus liquid, and this is the example of liquid or liquid plus gas, okay, plus liquid. Hope you get this thing now. Now let us find out, okay, in this topic, what are some of the different types of different types of solution. How do we classify solution? Why is it important to know how much one substance will dissolve into another? How much, okay, why it is important to know. And next is the how can we dissolve one substance into another faster. So these are the, so let us find out these four things. Okay, different types of solutions, okay, how we classify solutions, and the importance of dissolving one into another, and how do we dissolve one substance into another. So if we discuss about the types of solution, there are 5 different types of solutions. Okay, there are 5 different types of solution, that is solid liquid solution, liquid liquid solution, gas solution, gas solution, and solid solid solution. In case of solid liquid solution, solid liquid solution is solid is solvent, or solid is solute, and liquid is solvent, isn't it? This one, solid is solute and liquid is solvent. So solid, in this case, solid liquid solution, solid sugar or salt that are the solutes that will dissolve in a water solvent. Okay, another in number 1 is solid solid solution. Number 2 is liquid liquid solution, that is juice to water or milk to water. Adding juice to water or adding water to milk or milk to water is the example of liquid liquid solution. Now next, third is gas liquid solution. Okay, carbonated drinks. I gave example, the previous example you see here. This is the example of what? Gas liquid solution. Here the carbonated drink, the gas, okay, carbon, this gas, carbon is gas and this water is the liquid. Okay, so carbonated water is the example of liquid and gas. You see here, carbonated drinks or oxygen in water. So whatever the soft drinks you drink, that is Coca-Cola and Mountain Dew, Sprite, etc. Okay, those are the examples of the gas liquid solution. Next is the fourth one is the gas solution, atmospheric gas. It means that in atmosphere it is a mixture of gas, 70% of nitrogen, 0.3% of carbon dioxide, 20 after that I think 21% of oxygen and all. Okay, so whole night, and 0.1 or 0.2% of other respective gases. Okay, so the atmospheric air is the example of the gas solution. And now last is the solute solution. Example is the gravel and the cement. Okay, once we used to make, we built house and use cement and all, then doing plaster and all, gravel and cement are the example. Solid alloys like brass. Okay, brass is an alloy. So to make brass is this metal is, okay, usually formed by mixing two other metals, that is the copper and zinc. Okay, once the copper and zinc we mix it together, then we'll make a brass. Okay, this we call it alloys. So remember this term, alloy is the mixing of two, it's a product formed by mixing two different metals. Okay, so these are the different types of solution: solid liquid solution, liquid solution, gas liquid solution, gas solution, and solid solution. Now let us move to the next, okay, component of solution. Thus already we talked about the solute, solvent, and the universal solvent. So solute is the substance that dissolves. Okay, whatever the substance is there that needs to be dissolved. Okay, this is the solute. Example is salt, sugar, etc. Next is the solvent. Okay, this is the solute. Now next is solvent, the substance into which it dissolves. Okay, this it means solute, the substance into which the solute dissolves, it is the solvent. Okay, and example is the water. Basically, if it's a liquid then it's still a water. If it's a gas liquid, then it's a water. Okay, gas is the solute. So these things. Last is the universal solvent. Water is known as a universal solvent. Water is used as a universal solvent. It means that water is used in each case to mix, okay, to make a solution. So universal solvent, water is known as the universal solvent. Universal means it is used in every, most or not every, I can call it every, we can call it every or most of the solution. While making solution, okay, this water is used as solvent most of the time. That's why water is known as the universal solvent. I hope you understand. I hope you understood this thing. Now let us move to another slide. It is the, okay, that solution is divided, again solution. Okay, here solutions are divided according to its mixture. Okay, now here also solution is divided based on the amount of solute in the solution. Amount of solute, okay, it is depend upon the amount of solute in a solution. We can classify solution as saturated and solute means whatever will be mixed with the solvent, isn't it, to form a solution. So now here, based on the amount of solute, we have two different types of solution, that is unsaturated solution and saturated solution. Okay, unsaturated solution means it is a solution in which more solute can be dissolved in a given amount of solvent at a given temperature. So unsaturated solution is, it is a solution in which more solute, okay, it is a solution in which more solute can be dissolved in given amount of solvent. Where if we add, okay, if there is okay, if we are mixing a glass of water and sugar, so if you put 1 spoon or tablespoon of sugar and mix it, it will dissolve. Okay, again you are putting second spoon, it is getting dissolved over there. So that is what we call unsaturated solutions. Means still if you add, still you need to add more than 3, 4 or 5 tablespoons of solution to make it sweet, or to until and unless that the solid sugar remains down there in the bottom of the glass, until and unless. Okay, so now see here, this is a container of water, this is a liquid. Okay, you are adding sugar, again you add sugar. Okay, so you'll add sugar again and again until that, sorry, until you see sugar particles, okay, so cubes or sugar particles in the bottom, until, so that is unsaturated one. So it will still get mixed, okay, but in this is the unsaturated one. So you have to add sugar, that it will get dissolved, the sugar will get dissolved there. Okay, so there will be no this kind of thing, so all the sugar will mix here. Okay, then you will not get the thing, the sugar down there in the bottom, that is the unsaturated one. Matlab, your the capacity of the solvent, it has more capacity to dissolve the sugar, that is unsaturated one. Okay, once the, okay, that is you don't see sugar here. Okay, no sugar down there. Okay, once you started to see sugar down here in the bottom of your glass. Okay, now after 2 or 3 or 5, okay, after adding 2 or 3 or 5 spoon of 2 to 2 to 5 spoon of tablespoon of sugar in this unsaturated one. Okay, so once you start after 2 or 5, maybe you start seeing, okay, this sugar that is not dissolving with the solvent, this stage of solute or solution is we called saturated solution. So now no more solute can be dissolved. Okay, no more solute can be dissolved in given amount of a solvent at a given temperature. Okay, so this is the unsaturated one. Saturated means this 2 or 2 to 5 tablespoon is its, if its capacity is 2 to 5 tablespoon of sugar is what you put add in the water and still getting dissolved until up to 5 tablespoon, and that is the unsaturated solution, that it's still it has more solute can be dissolved. Okay, more solute can be dissolved, but in case of unsaturated one, once, okay, after adding 2 to 5 tablespoon of sugar, now you start after the sixth one you start seeing the sugar molecules down there on the bottom of the container or glass. Okay, this container or the glass, then this is called unsaturated, that this is called saturated solution. So now no more solute can be dissolved. Okay, put again and again after 7 8 tablespoon, you start seeing, okay, that all the sugars has been undissolved and remains down there in the bottom of the glass. Hope you got this one. Now saturated and the unsaturated solution, it is based on the amount of solute, how much solute a solvent can uh, dissolve. This is the thing. Okay, so here you can see saturated solution example, the unsaturated solution. Now you see here unsaturated solution, most solute dissolves here. So however it is put, you will not see any kind of, you will not see this molecule. Okay, this you will not see this molecule down here. All are mixed. Okay, all are dissolved. But in this case you say saturated solution. Okay, what you see, the sugar is has been added, the cube has been added, whatever it is, sugar or salt, it is added. Now you start saying that it is getting deposited here, not dissolving. So here it is not here, Malay. It is completely dissolved, but in this case it is not completely dissolved. So this is the unsaturated one, so it has the more capacity to add or to dissolve solute, and in this case unsaturated one must say it, there is no more solute dissolve, no more capacity to dissolve solute. Okay, and there is another one is also this, a supersaturated solution. Okay, now what happens, this supersaturated solution must say added crystals, whatever you add, okay, the added crystals grow means it not that it is growing there, but you can see that all undeposited one has been stuck out there, okay, in a large quantity. So this is the saturated solution, unsaturated solution, and the supersaturated solution. Let us move to the solubility. Solubility is, okay, let us go with the definition first. It is defined as the amount of solute that can be dissolved in a given amount of solvent. Okay, solubility means the amount of solute that can be dissolved in given amount of solvent. Okay, whatever the solvent is given there and the solute, okay, the amount of solute can be dissolved. So if example, if how much a solute salt is needed to 100 ml in 100 ml of water. Okay, if there is a glass, so it is 100 ml of glass of water is there, so how much salt will be needed to make it saturated one. Okay, saturated means after that, at a certain, after adding certain amount of salt, certain amount of or certain tablespoon of salt, after that no more salt will be dissolved. Okay, will be dissolved. So that in 100 ml of water, if you are adding 3 tablespoons of salt, it get dissolved. But after in the fourth one, if that remains down there in the bottom of the glass, then the solid it becomes saturated, super saturated, isn't it? So that three third spoon is now the limit of this, and it is that is the amount. The third spoon, the 3 tablespoon is the amount of solute. Okay, so this is called solubility. So different solvents, okay, different solids have different solubilities in water and liquids. Okay, knowing the solubility of a substances in water can be useful. So it is very useful once we know the solubility of a substance in a particular water. So it can help to determine how much sugar or detergent or salt or any ingredients we should use. Okay, if we are cooking a food or we are cooking something or we are washing clothes, then what we should know that how much the spices or salt, sugar in while cooking food we need. If we add more salt, it become bitter. Okay, more salty, bitter. We can't take that thing, eat that food. That becomes inedible. In if we put less sugar, and that if you are making a tea and if we add the less sugar, then it becomes the tasteless, bland. Nobody likes it. But if we put more sugar, more more than we need, and it becomes too sweet that we can't take it. Still, we don't like that thing. So the specific limit or the quantity that we need for balancing it. The balanced amount of solute is the solubility. Okay, so now next is, it is also helpful in chemical labs. Okay, so we should know the solubility, this thing, okay, that it is very helpful. Once we know that how much amount of a particular chemical we need to dissolve in something to make a medicine or to make some chemicals that is very useful to us, then then it becomes more helpful to us. Once if we are taking, you can see in many medicines, okay, so, or if you don't know, then please check out in your the backside of that medicine cover, that you will get different types of component, okay, different ingredients with, and along with it, its measurement, okay, is given there, that this milligram in milligram, this amount of chemical is added, this amount of chemical is added, another this amount of added. So that the amount is given, no, so that is the balanced one. If we take more than that, then it becomes poison to us. If we take less than that, it will not work in our body as a medicine. It will be useless. So to know that also, this solubility is very important. Next is, it also helps to reduce chemical use and waste. It's like same thing. Okay, so now next thing, so whatever we are dissolving the solute and solvent, it is not that only it depends upon the solubility, that this much of spoon of these things we need it, but along with that, there are different factors they are affecting, okay, directly or indirectly, while preparing this solution. There are very different types, okay, the very different factors are there. But basically, we will discuss here about the two main factors that affect the solubility of a solid in liquids. And these are the very important factors, and these, okay, so these two are the temperature and the particle size. These two are the temperature and particle size. Temperature means if a saturated solution of a solid in liquid is heated, okay, more solute can usually be dissolved. Saturated solution, you know that saturated solution, it is a solution where no more solute can be dissolved. Okay, but if you heat, give if you raise the temperature, if you heat that saturated solution with higher temperature, then what happens, its saturation point will now increase. Mane, if after adding 3 spoons of or 5 spoons of sugar in a 100 ml of water, it becomes saturated. Now once you heat this 100 ml of water, okay, the saturation point will be increased. Now you were putting 3 tablespoons. Now you have to put another 3 more tablespoon of sugar to saturate it. So this is how it works. So temperature, in case of uh, there is basic example, okay, even in this is very important, that if heating a particular, okay, if you are heating a cold water or a mild normal water, okay, what happens while heating a cold water, you need more heat, isn't it? So now while heating the normal water, you need less heat. It will heat more uh, uh, fast than the ice cooled chilled water, because it takes more time to more temperature, and it takes more time to become normal. So there you can see the two difference, okay, in heating a two different water. So like that this temperature is very important in case of saturation solubility. So if a saturated solution of a solid in liquid is heated, more solute can usually be dissolved in it. The reverse happen when a liquid is cooled. So if the liquid is cooled, okay, then now you cannot add 6 spoons of sugar. Now it becomes super saturated. okay, it will cross the limit of saturation point. So 3, in case of cold water, 3 tablespoons is, or normal water 3 tablespoons is the limit, or it is a solubility point. Okay, so to know the whole solubility thing, first of all you have to know solute and solvent. What is solute, what is solvent, what is solution, and next thing you have to know what is saturated solution and what is unsaturated solution. Just don't get confused with these two things. Now next is the particle size. Okay, the smaller the particle of solute, the faster they dissolve. If you can try with a sugar, okay, what to do, 2 tablespoons of sugar, you just grind it and make a white powder. Powder is sugar like glucose, or you can use glucose powder, and you just use a normal sugar molecule. So you add the same amount of sugar to, okay, 2 glass of 200 ml of 100 ml of water each. Okay, in 2 glass 100 ml of water, and you add the same amount of sugar in 1 glass and same amount of glucose powder in 1 glass. So what happens now, you dissolve it and observe what will happen. The glucose powder will dissolve faster than the sugar. Why? Okay, the question arises here, why? Because we are adding the same amount of solute in the same amount of solvent, then why the difference in dissolving? Because the particle size. You can see that glucose powder is soft, it's very powdery, it's powder, and the sugar is granule. So the granule takes more time to get dissolved in water as compared to the powder. So these two are the main factors, okay, affecting solubility. So before concluding this topic, let us revise. Okay, what is solution? It is a mixture in which the components dissolve in each other completely occur solutions. Examples are the mixture of salt, sugar and milk, salt and water, lemon juice in water. Now next thing you have to know, you only know, you have to remember that what is solute, solvent and solution. Solute is the compound which will be added or which will mix with the solvent. And what is solvent? The solvent, it is a liquid or a compound where the solute will be added to form a solution. Okay, so in case of this mixing salt water, it is example of solid and liquid. Okay, mixture solid and liquid. In case of carbonated water and orange, it is a liquid, but carbonated water is example of liquid and gas. Next is types of solution: solid liquid solution, liquid solution, gas liquid solution, gas solution, solid solution. Please go through the examples and for book. Component of solution, you can see solute, solvent and universal solvent. Water is known as a universal solvent. You know now the reason. So what is, let us, so okay, the two types of solution based on the amount of solute: unsaturated solution and saturated solution. Unsaturated solution is a solution in which more solute can be added or dissolved in a given amount of solvent at given temperature. Unsaturated ones is, it is a solution in which no more solute can be added or no more solute can be dissolved in given amount of solvent at a given temperature. Next is saturated solutions. Okay, you can see here the unsaturated solutions, no more solute dissolves. Saturated no more solute dissolves. Unsaturated more solutes dissolves, and supersaturated say added more crystals grow, added crystals grow. And last, go with let us go through the solubility. It is defined as the amount of solute that can be dissolved in given amount of time. So different solids have different solubilities in water and other liquids. Example, that powdered glucose and the sugar granules. Sugar granules takes more time to dissolve in water as compared to glucose. And next thing is, it can help to determine how much detergent or solid salt or sugar or any ingredients we should use. It is also helpful in chemical labs and industries, and it also helps to reduce chemical use and waste. So the two factors that affect solubility is temperature and size. Okay, the more the temperature, the more the saturation point is will increase. and the less the temperature, the reverse happens. In case of particle size, the smaller the particles of a solute, the faster they dissolve. So students, this is the topic solution. So please go through the slides, read it, listen it, and go through the book, refer the book also, and let me know what you understand, what you don't, and stay safe, keep learning and enjoy. Thank you.